There we go.
Great. I think we're now live. And Matt, I don't think we can see you anymore.
You can't see me?
No.
Oh, I can see me, but...
No, I can see him.
Oh, really?
Okay.
Yeah.
Can you see me? Can everyone see?
No.
No.
Camera's off to me.
I can see.
I can.
Some people can't?
No.
Maybe try turning your camera off and on.
Oh, I think if I click on Matt and then unclick, I can see him again.
Yeah, can people see me now?
That works for me as well.
People got me? Yes?
Yes.
Okay.
Yep.
So, should I just take it away, or?
Why don't I introduce you before we get
Okay,
started?
sure.
Yeah. So hi, everyone. Welcome to the MD4SG Colloquium series. We're so happy to have you all join us today for a talk by Professor Matthew Jackson. Matt is a professor of economics at Stanford University, and he's done prolific amounts of research on game theory, microeconomic theory, and particularly in the study of social and economic networks. And he's going to tell us a little bit about some of this work today. Matt is a fellow of many societies, including the National Academy of Sciences and the American Academy of Arts and Sciences, and he's also won numerous awards, including the von Neumann Award. So we're very pleased today to have Matt tell us about using gossips to spread information, theory and evidence from 2 randomized controlled trials.
So thank you so much. It's really great, a great enterprise, and a real pleasure to be here. And what I'll do, I'm going to share my screen here, and I will see, make sure this works. Okay, so people can see the screen? Great. So the organizers asked me to say a little bit before I get into the material on the networks and how to distribute information. The organizers asked me to say a little bit before I get into quite an echo. Maybe someone's not muted, or?
Yeah, the echo is probably from someone who wasn't muted.
Yeah. Okay. So the idea here is to start by just saying a little bit about the role of theory, especially in the era of big data. And I want to talk a little bit about a paper I wrote that talks about why we still need theory and what sort of its importance and role is and how that's been evolving over time. And so I'll start by just going through, is theory obsolete? Can data and field experiments be enough? And what about design? And part of the theme here today will be that even when we design new systems and we want to put them in the field, it's important to have theory that guides us both in how they work, how we want to distribute them, and what kinds of feedback we get. And before I go into that, I want to spend just a few minutes talking about the role of theory in general, and I'll start by just sort of, this is a little bit of an economist perspective. And when you look at what people say and think that economists do, that's evolved quite a bit over time. And so this is the first part, ethicists and artists. That's actually John Neville Keynes, who was John Maynard Keynes, the famous Keynes father. And the idea there was that that economists were essentially sort of philosophers who were sitting back in armchairs and thinking carefully about how things worked, and they described the world as it should be and how systems should work, but it wasn't really roll up your sleeves and get involved. Paul Samuelson was the person that really took it to the next level in terms of thinking of it as a science, not just as a philosophy. And there, the idea was, there are systems that we think work well and don't work well. Public goods was one of his main areas where there were substantial contributions. And the idea was, we can put together theories and then we can go test them using data and we can get feedback. And it was really using the scientific method to advance our knowledge. And that was, that sort of really, that philosophy began to change the way that theory developed in the 1950s and 60s and the way that people thought of what the enterprise was. And then you came along and you had people like Ariel Rubinstein, who has a very interesting piece, very nice piece that he wrote for his presidential address as a president of the Econometric Society, where he thinks of modeling as being sufficiently abstract from reality that he thinks of us as sort of fabulists or storytellers. The idea is that, you know, what a model does is give us insights, and we can play with different pieces of it, and we can understand how these pieces fit together, but we shouldn't take it too seriously. So it can teach us things about norms. It can teach us things, you know, in general about things like corruption or law and economics. There's a variety of areas where we can think of these sort of as toy models, but we shouldn't take ourselves too seriously. And so that's sort of a pushback saying, look, there's a big distance between what's going on in reality and what models are doing. The sort of counterpoint to this has been an area that developed, you know, as thinking of people as engineers. And this is really the birth of mechanism design and market design. And I think you can trace a lot of that back to Hurwicz's writings in the 1960s and 70s. And Hurwicz was trying to figure out, you know, how do you make an economic system work? And he was really interested in the sort of debates between capitalist and communist systems and whether you could have controlled centralized economies or whether things had to be done through markets. And he really set the framework from that. Al Roth sort of took that to a different level in pushing very practical design, where you do things like design systems for putting people in schools, for distributing kidneys, the auction design literature that was born in the 1980s and really took off. You know, these are all examples of modern mechanism design, and it's taking the theory seriously and putting it in practice to try and improve systems. And there, it's really engineering. I think that, you know, there's a nice paper recently by Esther Duflo a few years ago, which sort of takes that to the next level, which is, you know, when you actually get to putting things in practice, it's not trivial. And there's all kinds of problems that arise, and taking things from paper to the field takes things in terms of a whole different level of complexity. And she thinks of people as plumbers and tinkerers. It means that, you know, we have some idea of how the system should work, but you really got to roll up your sleeves, try things, try them again, put them in practice, and move around. And so I think that these, you know, sort of think of, I think it's always useful to have in mind when anybody's doing something like mechanism design for the social good, you know, what is it that we're trying to accomplish, and where do we think we fall in this? Are we doing pure theory? Are we scientists? Are we engineers? Are we telling fables? Are we, you know, trying to design a system? And in all of these, you know, theory plays a role, and it plays a different role in all of these in terms of what it's doing. And today I'm going to talk about a system where it's going to go back and forth into the field and then back to the drawing board. You know, and part of what I'll be talking about today is sort of this diffusion of microfinance project that we've been working on for now a decade. And, you know, the theory gives us models of how networks can be helpful in getting people to participate in a program. And then we collected data, analyzed that using some of the theory, and then we went back and used this to try and engineer new systems and put them back in the field. And so I'll tell you about that. And then one of the things I want to talk about, and I think is very important and probably not so well understood yet, is the fact that when we put new systems in, new mechanisms, and we put them into the field, they can change the way that the society is acting. And the fact that it changes the society means that changes the effectiveness of these systems, and doesn't necessarily mean that we accomplish what we want to accomplish. So that's an important feedback, and I want to spend some time at the end of the talk today giving you evidence actually from our field that you know, the actual implementation of a mechanism can change the way that people act and can have feedback that can be in some cases quite negative. And so it's sort of an interesting dynamic. You know, in this paper I wrote about the role of theory, that I talk about sort of the evolution of theory and what's going on. I'll skip that today just in the interest of time, but there's been an interesting evolution of theory and what kinds of things we're looking at, and game theory has played an important role in that development and in understanding incentives and understanding how these systems work. One thing I want to encourage people to do is ask questions at any point. So if you're interested, just you can unmute and hop in and ask questions as we go along, especially clarifying questions, or even if you want to ask me to dive in deeper on a particular topic, I'm very happy to do so. Okay. So the second part, then, what we really want to zero in on today is that when we do have programs that can be designed for the social good, we need to get people to participate in them. They're not always designed systems where the participants are completely aware and all required to participate. And so one question is how we can inform people. How do we seed information into a society and get people to participate? And then the one question that we'll ask at the end is, once we get people to participate in these kinds of new systems as formal institutions, can that change the interactions in the society, and in this case actually have some backfiring? And in particular, what we're going to be looking at is distribution of a Grameen style microcredit system. And if people are familiar with the Grameen style, this is one where you put, say, we're giving microloans out, so people don't have any credit and they don't have any collateral. You're giving them loans, and one idea is that you give them loans in a group of, say, 5 individuals, and then those 5 individuals are jointly liable for paying back the amount, so that if any single person doesn't make their payments, then the whole group is called into default. And the idea of that kind of system is that changes the incentives. And now it gives people incentives to monitor each other and to help each other out if they can't make payments, so that the whole group performs well. And this was something that won a Nobel Prize some years ago for design. It's an important system, and this kind of system has been used dramatically around the world in terms of trying to alleviate poverty and get loans to people who really need them. And so what we're doing is looking at a system where we're trying to get this into the field, and the question is, how do we seed that? And then I want to take you through at the end is, once people start participating in this loan systems, how does that change the fabric of the society and actually feed back into whether these loans are good or bad in the end? So a sub-theme here then is interaction of informal relationships with formal institutions. So these formal designed markets and informal relationships interact. Sometimes they substitute for each other. So in the case that we're going to be looking at, once we get people to participate in these loans that are coming in from a bank, then that's going to change their incentives to borrow and lend from each other on the side. And so there's going to be a substitution. These things can also complement each other. Sometimes formal markets can help informal relationships and vice versa. But in today's, we're going to be looking mostly at substitution. And both of these kinds of things affect economic behaviors and welfare, and we know very little about how they interact. So we have theories about how mechanisms work, but we also usually view them as the mechanism in isolation rather than how it fits into the society more broadly. Okay, so I'm going to take you through these papers, and here we're going to be using informal networks to spread information about these formal loan programs, and then we're going to be looking at how these formal loans change the informal relationships in the society. And actually, as Ken Arrow, this is just a quote from Ken Arrow, and it's it's hard to find any topic that he didn't think pretty deeply about. And here this quote says, this leads to an important and long-standing question: does the market, or for that matter, the large efficient bureaucratic state, destroy social links that have positive implications for efficiency? So he's asking, whether or not when you put in a design system, how does that change the societal structure, and does that have a feedback that could, change the actual welfare implications of the system itself? And the idea here is, networks are going to be shaping information flows, and I'll go into this in more detail as we go along. Okay. In terms of the theory today, what I'm going to be doing is talking a bit about how people get information in networks and how networks spread information, and then also how people become aware of other people in the network and their position in the network. And that's going to be sort of an important theme in understanding how networks change and spread information about participation in these kinds of programs, and then ultimately how that feeds back. So what I'm going to do is start with data and background, and just talk about what what the system was and what we were doing, and then talk about how the networks affect these formal institutions. So how we seed information affects the awareness of this microfinance program and the participation in it. And then I'm going to ask a question of how we can find and best design the system for actually seeding information about a new program. And then finally, I'll talk about how the formal institutions drive changes in the informal networks. So just in terms of a preview, what's going to happen is when people start getting loans, they're going to stop interacting as much with their neighbors, and the local social networks are going to decrease in both density and activity, and not only for people that get the loans, but also for people who don't get loans. And again, feel free to ask me questions at any point in time and to stop me if something's not clear. So what I'll start with is just a quick tour of measuring centrality for diffusion, as this is going to be sort of important in understanding what comes later. And in terms of the background on this project, originally we were partnering with a bank that was trying to distribute this new, the Grameen style lending system in southern India near Bangalore. And the idea was that microfinance participation varies very widely in otherwise similar villages. So they would go into some villages and they would try and get participation. Nobody would show up. They would go to other villages and they would end up getting a lot of participation. So near zero in some places, closer to a half. And in our data, it's going to go from 7% in some villages to about 44% in terms of eligibility. And they were trying to understand why and whether they can improve participation in this program by trying to better design the way that they were getting information out. And one thing that it was very important was for them, they were using word of mouth to get information out. So these are villages that are relatively poor. It's difficult to get information out to people. A lot of people, some people have cell phones. You can SMS them, but they get bombarded by so much spam that way that it's not a very effective method. And so a lot of this was just done by word of mouth. And I won't go into all the details as to why that's true, but that was the method that they chose to get information out. And so what they were doing is going into a village, trying to find the central people in the village, telling them about the program, and then saying, tell your friends, and let's hope that this diffuses through the village, and then we'll get lots of participation. Sometimes it was working, sometimes it wasn't. And so one idea is, maybe it's that when they went into the village and start telling people, if you find really central people in that village, then they can be very effective at spreading that information. If you find people that are fairly peripheral, and those are the people that you first tell about your program, they're not going to be a very effective distributors of information, and you're not going to get much participation. And so that's what the problem that we started exploring in this. So the data that I'll show you, 75 rural villages in Karnataka. So this is around Bangalore. The bank entered 43 of them and offered microfinance. It didn't enter 32 others. And I'm going to use that later on to try and see how the effect of this new program, how it changed the structure of the village social networks. And it's because basically the bank in 2009 hit a financial crisis and they stopped lending. And so they just stopped the program midway and had entered more or less a little more than half the villages before that happened. And so we surveyed networks before and after, and then by comparing what happened in the villages they entered to the ones that they didn't enter, we can begin to figure out what's the impact of this program on the social structure of the villages themselves. Okay, so I'm not sure how much people know about Grameen style lending, but it was a very simple system. These were loans given to women between the ages of 18 and 50, sometimes 55. They were 10,000 rupees, which was roughly $200. They were given over a 50-week period, roughly high credit card interest rates, so 30 to 40% interest rates. Just to put that in perspective, money lenders in these villages usually charge around 50%, sometimes more. So these were loans that were non-secured, so there wasn't any collateral. If you didn't pay back, there was nothing the bank could do other than say, you can't borrow from us in the future. And the Grameen style meant that what they would do is they would take, when women applied, they would put them in groups of 5, and then those groups of 5 were held jointly liable, so that if any one of them didn't pay, the whole group was put into default. And so none of them could get loans in the future. And actually, the repetition of loans is an important incentive. Getting these over time is important for the people, and so they have a high incentive to repay. The repayment rate in our data was on the order of 99%. So these are loans that people paid back in almost all cases. There was occasionally delayed payments, but very few defaults in the whole data set. Okay, so there we are in Karnataka. Villages are fairly poor. Think of a few dollars a day in per capita income, mostly agriculture, some light manufacturing, brick production, other kinds of things. The villages in the village center tend to be pretty tight. You'll see a lot of temporary roofs and buildings that people live in. And so what we did was we went in before the bank entered and we mapped out the social structure. And so we did that by asking a bunch of questions. So this picture is of a village, and each little dot is an adult, and the adults are grouped into households. So one of these little clusters of 5 to 10 or 2 or 1, these are all households with the adults put together. And then we would ask them a series of questions. So this is the network that we obtained by asking them, if you needed to borrow 60 rupees for a day, who would you go to? And so there's a link drawn from one individual to another, the gray lines, if somebody borrowed rupees from another individual. So that gives us a network. And we asked a series of 12 different questions. Who do you go to temple with? Who do you go to for important advice? Who would come to you to borrow kerosene or rice? Who would you go to in an emergency for medical help? So we have a bunch of different networks. And what these networks will do is allow us to figure out who's connected to whom in terms of who might be talking to whom, who could spread information about this loan program to whom. And so, when you think about one of these typical villages, they'll have about 200 households. The average household will have connections to maybe 10 to 20 other households, on average somewhere in the 13 to 15 range. And so that's the basic network structure that we're looking at. Okay, you can color, this is a graph where I've colored the households by caste designation. You can see community structures here. So there's splits along caste lines, there's splits along gender lines. There's a richness to the data that I won't have time to go into, but it does matter in the background, and I'm happy to dive into that if people have questions about how it matters at some point. Okay, so basic question then, do the initial injection points matter? How would we measure their role? And there's a large literature says that, look, if you want information to diffuse in the network, it makes a difference who the seeds are. And this goes back to Simmel, more than a century ago, Katz and Lazarsfeld about opinion leaders. There's a lot of literature on this in terms of finding the right seeds for diffusing something. And what we started with was, how do we find these people? How do we measure them? And who's important? And I'll start with just a little bit of theory behind the scenes that'll be very helpful in what we do later on. So, if we think about the most basic way of measuring centrality in a network, if we want to find who's the most central person or who's the most important person or might be best at spreading information, we could just count the number of connections they have. So on the left, you see somebody who has 7 connections. On the right, somebody who has 6. Those would be people that we might want to target if we were trying to get information out because they have the most connections. Okay, what's the problem with this kind of counting? Obviously having just, when you look at first degree neighbors, the number of people that somebody's connected to, that doesn't pick up the whole story. So here I've we have two different individuals who both have two connections, but obviously the person who's connected to a 7 and a 6 is much more central than the person who's connected to two 2s. So what we'd like to do is, if we really want to spread information, we want to go beyond just first degree neighbors. We want to be looking further out into the network to see how well somebody's connected. Okay. Eigenvector centrality is the standard kind of measure that people think of when we think of this kind of issue. And the idea here is that centrality is proportional to the sum of your neighbors' centralities. So instead of just counting how many links somebody has, what we'll do is we'll think of somebody as being more central if they have more central friends. And so we'll add up the centrality of their friends. So we have that, CI, the centrality of some particular node I, is proportional to the sum of their friends' centrality in the network. And here, I'm happy to answer detailed questions about the math at any point, but I'm just going to take the matrix of the network as being a 0-1 matrix, where I'll think of two people I and J as being connected. We'll code them as a 1. If they're not connected, code them as a 0. You can think of this as an undirected network, so that if I is connected to J, then we'll think of J being connected to I. So this will be a nice symmetric matrix. So that's what's going to encapsulate the structure of the network. And then if you want to think about this idea that CI is proportional to the sum of the friend's centrality, you can write that in matrix form by saying that lambda CI is equal to the sum of the J's of Gij times the Cj's. And in matrix form, that becomes lambda C is equal to GC. And so what we're looking for in terms of C, this is just an eigenvector of the network itself, and G. And so it has the Perron-Frobenius theorem tells us this has a nice unique solution that's going to be non-negative. And so there's some nice properties here in terms of the eigenvector centrality measure. Okay, so if we go back to this picture I had before with the two 2s, then the person here has a 0.31. The person, the other 2 has a 0.11. So now the eigenvector centrality is picking up the idea that the one person is much more central than the other, because of the fact that they're better connected in terms of their neighbors' connections. So they both have 2 connections, but we're getting a difference in terms of the overall weights here. Any questions at this point? Is that pretty clear? Nobody's piping up, but okay. So one thing we did in this study was we defined a third measure of centrality, which we called diffusion centrality. And the reason was because of the following. Degree centrality, the first one we started with, just counts your immediate neighbors. That's not really saying what kind of reach I'm going to have in terms of diffusing something deeply into a society, because it's just looking at this first neighborhood. When you look at the eigenvector centrality notion, it goes too far in the other direction. It's sort of a completely iterative, because my centrality depends on my neighbors, they're depending on their neighbors, theirs is on their neighbors. There's an infinite regress. And so it's going sort of an infinite level. And so what we did was we thought, well, actually what we're doing in diffusing something is, we start with a given node, we're going to be spreading information, it's going to be spreading probabilistically, and it's probably not going to spread forever. And so what we did was say, let's define something directly in terms of that diffusion process. And we'll say, how many nodes end up informed if we inform some person I? And then each informed node tells each of its neighbors with some probability P in each period, and then we run that for T periods. Okay, so what we're going to do is just model the diffusion process directly, and then we'll call a node more central if it leads to higher diffusion than somebody else, right? So we have some initial node in a network. Let's say P is 0.5 and T equals 4. Then what we're going to see here is we can go through and just simulate this. As a half a chance that they tell a friend. So T is the number of periods we're going to run this for. So first period, they happen to tell one of their friends. Second period, that person tells 2 friends. The initial node tells another friend. These are people randomly bumping into each other in the village talking, and P is capturing how often they're doing, how frequently they're doing this, at what rate. and T is saying how long is this going on. So, after 4 periods, we'd have 13 people informed. So that would give us a notion that this person has sort of a reach of an expected value of 13 off this simulation. We could run a bunch of simulations and so forth. And then we could do a different node, do the same thing, and basically we get a different number for them. And then we have relative efficiencies of different individuals in the system for spreading information. Now, obviously, if you're going to spread, if you're going to pick multiple nodes, you want to group them in certain ways. There's that turns out to be a hard problem, as shown by Kempe, Kleinberg, and Tardosh. So there's some issues about sort of finding the right sets of nodes and so forth. I won't go into that in detail here, but this is sort of a first cut at that, is just measuring how good are single nodes at disseminating information. Okay. In terms of just putting these 3 things together, if communications just happens once, diffusion centrality is the same as degree centrality, because all you can do is reach one set of neighbors. It doesn't have a chance to go any further. If it happens many times, if T becomes really large, then this is eventually going to converge to eigenvector centrality. So it'll have a chance to go from friend to friend to friend and friend and so forth, and it's going to look like an eigenvector centrality calculation. So, the 2 extremes of diffusion centrality capture these 2 standard notions, and in between is where a lot of the empirics is going to live. And, from best estimates in the data, P turns out to be about 0.2, and T turns out to be somewhere between, best guess usually 3 or 4. So often we're going to be living in an arena that's quite different from either of the extremes. Okay. So, theorem, take a connected aperiodic network. If T equals 1, then diffusion centrality is proportional to degree centrality. If P is large enough, so it's bigger than 1 over the first eigenvalue of the matrix, then as you run this process infinitely, it converges to eigenvector centrality. If P is smaller than the first eigenvalue, it turns out that this thing corresponds to something called Katz-Bonasich centrality, which is another notion which is sort of akin to eigenvector centrality. Okay, so what we did is then just look at the data and then try and figure out which kind of centrality measure matches the data. And so here, I'll just show you quickly. This is each point in this graph is a village. And so there's, on the x-axis is the average degree centrality of the first people that the bank talked to, that they seeded the information with. So what they did is they just followed a simple rule of thumb, looked for shopkeepers, self-help group leaders, and teachers to try and spread the information, and then spread the information that way. So here a point then is how central were these people in terms of degree. So for instance, if you pick the bottommost point in the whole graph, that's a village with about 17, where the first people they talked to, the teachers and shopkeepers, had about 17 other households that they were interacting with on average. And then there's the participation rate, how things eventually spread, what kind of participation did they eventually get on the y-axis. And they ended up that's the 7% village. The highest one, the 44% there, you can see is a little bit above 20 connections. Okay, what's with this graph? It's saying basically there's no relationship between how connected, in terms of just counting degree, the initial nodes were and what the eventual take-up was. If you do it with eigenvector centrality, you get a positive and significant relationship. So the eigenvector centrality does a much better job of predicting who the right nodes are to spread information. And ultimately, diffusion centrality here, we did this right at the T being the diameter of the network and P being the proportional to 1 over the first eigenvalue. And here you get the best fit. And if you do a regression on this, you can look at what's the relationship between how much microfinance participation there was and the centrality of the people that they used to spread information. And so I've highlighted the 2 that turn out to have significant relationships. If you look at the the magnitudes are different because of the scaling is different on these notions. But if you look at the R squared, sort of how much of the variation in participation across villages can you explain using these different centrality measures, the diffusion centrality does better than the eigenvector centrality. And degree basically doesn't explain much more than what you get just with the demographics of the villages. Okay, so now let me get to the gossip part of this and the sort of the title of the paper that was distributed. Okay, so what we could do from this first step was we could go back to the bank and say, look, what you want to do is you want to find the most central people in the village. And how do you find the most central people in the village? Well, it wouldn't be very efficient for them to go in and interview everybody in the village and then try to disseminate information that way, because they, once they did that, they just tell everybody in the village. So mapping out the network wouldn't be a very efficient thing if they didn't have the network information already. So one question is, how do you identify good seeds for spreading information in a society without actually seeing the network? Okay? And so what we thought about was, well, if you asked me who would be a good person for spreading information around Stanford, I have some idea of it, and I might be able to tell you, look, these are the people that I think would be well placed and could do that. So one question was, we could go into the villages and ask them explicitly for nominations. And one question was, how well would they do at that, and why would they be able to do that well? So the idea is, we'll ask them, and obviously we can't go in and ask them, how eigenvector central, who's the most eigenvector central person in your village, but we could, ask them questions like, if we want to spread information, who would be a good person for doing it? So we went in, and we used, here we went into 33 of the villages, roughly 200 households per village. And we asked adults who are the best people for diffusion. So we asked them two questions. If you want to spread information about a new loan product to everyone in your village, to whom do you suggest we speak? If we want to spread information about a music event, drama, fair, and so forth, to whom we should speak? We did this just to try and say, one sort of a financial thing close to what we were doing, another sort of a social program. We wanted to see whether they would answer differently based on different types of diffusion. It turns out there's almost no difference between these, no detectable difference. So I won't sort of distinguish that further, but the idea is we go into the village, we ask them who's good, and we see if they can name people. And let me say a little bit about the background here. So, if you study social networks, there's something that's really fascinating about what we know about our neighbors. It turns out we know very little about what our network looks like beyond ourselves and our immediate friends. So if you ask people which of your friends are friends with each other, they're better than at random at sort of naming them, but they're not really that great. If you ask them, so this is something that David Krackhart has studied and a number of other people, if you ask them, name the friends of your friends, it's very difficult for people to name friends of friends who actually aren't already friends directly. So people aren't very good at sort of naming what their second degree friends look like. And then if you ask, give people like suppose you work in a company and I give you a list of all the people in your unit, and now I say, draw the connection of who actually, regularly emails whom or who goes to lunch with whom or something like that. People aren't very good at doing stuff outside of their immediate arena. So there's reasons to doubt that people are going to be very good at naming central people. But it turns out that they can. So people do well. And then I'll give you some theory as to why this works. So people tend to name the same people. Only 5% of the households are actually named when people go into this. And then conditional upon being named, the people are naming a few people, and then those people tend to be named a number of times. So here they were named 9 times in the median, and they turn out to be highly central. So here what we're looking at is diffusion centrality. Remember I told you it was about 0.2 and 3 seems to be the best measure of diffusion centrality. If you look at the diffusion centrality of the nominations, so on the x-axis is how many nominations somebody received, and you can see some people got named a huge amount of times. And then the their diffusion centrality is on the y-axis. So there's a pretty tight relationship. In fact, if people are named a lot, they tend to be highly central people. So people are naming highly central individuals. So if you look at the, sure.
Yeah, one question about the graph I have is how do you measure the degree centrality in the village? So on the x-axis, you ask people who they, and you count the number of people, the number of times people are named. But on the y-axis, how is it computed from the villages?
Right, sure. So the diffusion centrality we computed by these were villages we'd already mapped out the social networks for. So let's say I name a certain person. So this is, in an experiment, we already have mapped out the network. So we're just trying to see whether they're good at naming the central people, but we've seen the networks themselves. And so this experiment was just to see whether people do a good job at doing that. And so once we have the network, we can do the calculations of everybody's diffusion centrality and then map out who they're naming. Yeah. So that.
Okay, yeah, that makes sense. Thank you.
Yep. Okay, so people do well.
Another quick question.
Sure.
So I think the villages are quite varied in size. How are you normalizing between them in this data, these plots you're showing us?
Yeah, so the villages vary in size, but not dramatically. So most of the villages, I don't remember the standard deviation offhand, but so take the average as close to 200 households. They varied from roughly about 170 to 230 households in terms of the first standard deviation. There wasn't anything, I don't think, below. I don't remember the min on the number of households off the top of my head, but the bank had targeted villages that were very similar to begin with, and so there's not that much difference.
I see.
But you're right. Village size is something we control for when we do some of the regressions. And so, when we're looking at these things, there's village fixed effects in some of these things, so that is an attempt to to track what's going on in different villages, because the diffusion centrality is going to be, you're going to tend to be higher in larger villages just because you can reach more people.
Right.
So it is going to work that way, and so the village fixed effects will take care of some of that. Yeah.
Okay. Thanks.
Okay, and so basically you can find people by, and here what we look at is sort of leadership status, which we defined as being a teacher or self-help group leader or a shopkeeper, and by looking at combinations of somebody was both nominated and leader, there's about almost a 50% chance that they're going to be in the top 10% of the diffusion centrality, whereas if they're not named, not a leader, there's less than a 10% chance. So by using both the status, so leadership gets you up to about 17%, and then nominations get you up to a little more than 20, and using both together, you can find fairly central people fairly easily. And then people that are repeatedly not nominated, really that dramatically increases it. So you're able to find people. And I'm just going to sort of move through this quickly, and then we can get to the last part. So, what's the gossip coming in? So one question we ask is, how is it that when somebody lives in a society that they begin to know other people's positions, even though they can't draw the network, right? So as I told you before, give people a piece of paper with all their friends, the possible community that they live in, all the names there, ask them to draw the network. They're good at drawing their own network, immediate network. They're not very good at drawing the bigger thing. So how is it that they're picking out these highly central people when they can't really draw beyond their own immediate neighborhood? And so the story here is that this is where the gossip comes in. If I'm embedded in a network, I'm hearing information all the time about other people. So I'm hearing information, Arun moved to Stanford, Matt has a new MOOC, Esther won an award. These kinds of things are spreading through the network, and I'm getting information that's hitting me. And you can think of this as sort of the reverse process of diffusion centrality. Diffusion process, we were thinking of that from the node's perspective. How far can I reach out? Now we're thinking about this from the listener's perspective. But the idea is, if I'm sitting in a village for a lot of time, I'm going to be hearing gossip about different individuals. Somebody that information gets to me more about has to be somebody who's better placed and better at diffusing information. Somebody I hear very rarely about is somebody who doesn't have as good connections, and it's harder for them to spread information to me. So what the theory is suppose somebody just does a really naive thing. I just sit there and I count the number of times that I hear about different individuals, and people I hear about a lot, I think must be very central and important, and people that I don't hear about very often, I'll put lower down the ranking. And so what you can, so I just track the number of times I've heard this, and that's something that people do very easily. So mentally, just tracking, do I hear about somebody a lot? Do I hear about them very seldomly? That's something that's fairly easy to do. And this is just from the listener's perspective rather than the broadcaster's perspective. And so what's happening here is now I'm going to hear more about people that have lots of paths to me, and not hear about people that have very few paths to me. And so what you can prove about this is every individual's ranking of others under network gossip will eventually converge to the ranking of diffusion centrality for a large enough P and a large enough T. And in fact, it'll converge not only in terms of rankings, but actually in terms of the cardinal ordering as well. So the relative frequency with which I hear people, if you give me enough time in this village and things are spreading with a high enough probability, I'll be hearing about the most central people more often than the least central people. Okay. So the theorem is take any connected aperiodic graph, every individual's network gossip converges to diffusion centrality for any P bigger than 1 over the first eigenvalue, and T that's a random function of the network. Okay, so then we did, I'll just kind of breeze through this in terms of the timing because I want to get to the last part. Now we did some controlled experiments to see whether this works, and indeed it does work. So here we took 210 other villages. For some of them, we randomly seeded things. For others, we sort of looked for village leaders, village elders. And then in the third one, we asked for nominations of who are the best, most central people and good spreaders. And what we were doing is giving information about winning a cell phone. So we were just worked with a cell phone company that wanted to give cell phones out to these villages. And people could, if they participated, they either got money or a cell phone. And so what we were doing is telling people, look, tell your friends about this opportunity to win either money or a cell phone. And we seeded it either randomly with village leaders or with this nomination process. And I'll just show you sort of what the outcome is here. So you see the random, the participation rate was sort of the middle with leaders. In terms of the elders, we got the least participation, and with the gossip algorithm, we got the highest level of participation in terms of, these are sort of numbers of people that were informed per seed that we're getting. So we're getting higher levels of participation by using the nominations from gossips than others. So basically, there's a theory here as to why it should work, and it does seem to work in practice. It's seem to be a good way of spreading information. Okay, so let me just move on to this last part briefly, how networks are being changed by markets. And this was something that we were serendipitous to be able to do, so that the bank had entered some of the villages and not others, and that was hit by the financial crisis. It was not a controlled experiment in the sense that we didn't randomize which villages they went into first and which ones they ended up not going into. But from what we understand of how they trained, what they were doing is just they had different branches and different people working in different villages, and it was just who got trained at which point in time. But it's not a controlled experiment, so we have to take that into account. So we surveyed the 75 villages in 2006. 2007 to 10, they entered 43 villages. They had to stop because they started, the financial crunch that hit in 2009. They suspended the program in 2010. In 2011 to 12, we resurveyed all the villages, and then we can see how the networks changed from before the microfinance was offered to after. Right? So 43 villages got loans, 32 did not. Average degree, these are just sort of like how many households is each household connected to, roughly similar. The clustering is similar in these villages, average distances. So like the structure of the graphs looks very similar. Self-help participation, fraction of the population with savings, caste variables, whether they're otherwise backward castes or general merit castes, education levels, the size of their houses. There's a slight difference in terms of the average number of households, but it's not statistically significant. So, the villages look roughly similar. And actually, when you look at this is a geo placement of the villages, I took out Bangalore, so you can't tell where exactly this is, but the villages that they entered compared to the ones they didn't, there's not any systematic difference in sort of where they're located and so forth. Okay. Any questions just about this? So they entered some villages, they didn't enter other ones. And so now what we're trying to understand is, you've used this new mechanism of Grameen lending in some villages, and that gives people access to formal loans. What's going to happen to their networks? Is that going to change the structure of the society? And in particular, the first cut you can do is look at the non-microfinance villages before and after, and then the microfinance villages before and after. And let's just look at the density of the networks, the overall density of the networks. And here what you see is about, and one thing that's happening in these villages is there is some turnover and some change in the sense that more people in some of these remote villages are starting to work outside of the villages, and their networks are sort of expanding outwards. So you're losing some density of the network, but you lose about twice as much in the microfinance villages as the non-microfinance villages. So it seems that actually having access to loans is affecting the structure of the social networks in these villages. And one thing you can do is you can also try and figure out who's losing those links, right? So one story for this would be, okay, well, a bunch of people got loans. They don't need to borrow and lend from their friends anymore, so they stop interacting with as many other people in the villages. But it's only the people who got loans that might happen to. So one thing you can do is propensity score to try and figure out who are the people that would get loans, who are the people that wouldn't get loans, and now we can compare them, in the villages that got loans compared to the ones that don't. We can do a side-by-side comparison, sort of match up people who would have gotten loans and see what's happening to the dropping in links there. And so the propensity scoring, we put people into highly likely and then low likelihood of getting loans. And this is just we use a random forest algorithm for doing this, just standard machine learning stuff. And by looking at all the characteristics we have, the people that we categorize as high propensity to get a loan, usually about 46% of them get loans. The ones that we categorize as low, they're taking it up at about a 4%. So the categorization seems to be pretty good in terms of picking out who the people that would really get loans are compared to the ones that wouldn't. And then I'll sort of skip through some of the backgrounds, but what we begin to see now is when you look at these link probabilities, sort of the changes in link probabilities, it's not just the highs, the people that are getting loans that are dropping their links, but you're also losing links to the lows between the highs and lows, and you're also losing them in the low category. So it's not just the people who get the loans who are dropping links, but it's also the people who didn't get loans that are losing links. I won't go through the details, but in the new paper on this network change, we then sort of think through what's the process by which this mechanism is affecting not just the people who are participating in the mechanism, but it's also affecting the people who aren't participating in the mechanism. And the basic story here is that there's externalities in network formation. So if I want to meet people, and more or less the way this works in these villages is there's a town square. People can go to the town square, hang out, meet other people, and the more active that town square is, and the more that the highs are participating and so forth, the more attractive it is for lows to go. And the basic idea is once microfinance comes in, the highs spend less time hanging out in the central square. And if the highs are spending less time hanging out there, then the lows have less interest in going there, and the whole thing deteriorates. So it's not just that the people who got the loans are spending less time socializing, but the whole village spends less time socializing, and so they all lose the relationships. And not only do they lose the financial relationships, they also lose advice relationships and other kinds of relationships. And so you can look, the advice network is dropping at the same rate that the borrowing and lending relationships are. So actually the low propensity people's advice network and their borrowing and lending networks are seeing a dramatic drop, even more so than the highs, and it's happening sort of systematically across the network. So you're seeing a big effect. So what do you take away from this? First, just in terms of network formation, you get a spillover, so that the fact that some people's networks are changing is affecting everybody's networks. These links are not independent, and this search helps explain that. But I think, from a mechanism design for social goods perspective, one of the most important implications here is that having access to this formal system actually changes the social fabric, and it has unintended consequences in the sense that these lows, the people who aren't participating in the loan program, are actually losing relationships at an even higher rate than the other individuals. And there's non-money relationships that are being affected. There's some evidence that this happens asymmetrically, so it could increase inequality. And you sort of want to take this into account in mechanism design. So sort of closing thoughts, I think, for mechanism design for social good is that any kind of institution or thing we put in place operates in conjunction with a bunch of informal networks, economic and social ones, and they're intertwined, and that so changes in one affect the operation and impact of the other, and we sort of need better understandings of the consequences. I don't think, I wouldn't take this to say that it's a bad thing to go in and offer loans in these villages. It's just that it's operating very differently than what we had anticipated, and that's something that we should know and somehow build into our understanding of how to design mechanisms and design systems that are going to help individuals. If it's changing the way that they interact, that's something that's very important to take into account and understand. So let's see. Good point to stop. Actually, I have one quick advertisement. I have a new book coming out next week called The Human Network, where I actually spend some time talking in more detail about some of these issues and how these things interact. It's probably a good time to stop and.
Yeah, thanks so much, Matt. We have about 10 minutes now for questions, if people had questions they wanted to ask.
Let's see if I can exit the.
So I have a pretty basic question about these tools that you mentioned. So I've never heard of them. They sound very interesting. Or maybe I think I've heard about them vaguely, but they sound very interesting. So the idea is that you have a collection of people, you're sort of giving them a loan, and are you leaving it to the people to decide who's going to pay what amount, and what are what incentives do people have to not contribute anything, right? And just kind of to pay the loans.
Yeah, actually, so microfinance now, there have been a bunch of different systems that have been tried. The one that we were using with this bank, and in particular, sort of goes back to the original Grameen structure, is one where people were grouped into groups of 5, and each person had their own loan. So each person in a group would get a 10,000 rupee loan, and each person would make their own private payments to the bank. So the bank would come back every 2 weeks, and you were responsible for coming up with some hundreds of rupees at that point in time. But what the joint liability means, if if any one of the people in my group turns out not to show up and not pay, then that makes a mark on my loan. So my loan is now marked as Matt's in a bad group. And that means if I don't somehow, so that puts the incentive on me to make sure that my friend is making the payments. And then if that person ends up defaulting and never paying that money, then I can't borrow from the bank anymore. And so that sort of changes the incentive structure and says, look, the bank has problems. They can't go into these villages and see who's got money and who doesn't and who can make payments and not. But the idea is that these friends have better information about who has money, who doesn't have money, who can make payments. And if my friend really can't make a payment, I might even pay for them. But the money is, each person gets their own 10,000 rupee loan in this case.
So these groups of 5, does the bank decide what group of 5, or do people come in together and say, we want a group of 5, and everyone is consented to the group?
Right. So the way that this worked in our setting was that people could come in groups, and the bank could put groups. So some people came together and said, oh, here's my friend or my cousin or whatever. We'd like to be in a group together. Often they came in groups of 2 or 3 together and said, we'd like to apply and we'd like to be in the group with this other person. The bank had discretion over that, and there's some research. There's trade-offs. So if you put people who are really close to each other, really close friends in the group, the advantage is they really know a lot about each other. They can monitor and help each other out, but they also have some more incentives to collude. That's not quite that well understood at this point in time, but what it does do is these groups tend to work very well, and the bank in some cases would break up groups that came together and say, sorry, we're not going to put you in the same group because it looks like your siblings or your close cousins, or they also worry about correlation. So you don't want all the people in the group to be somebody who all involved in silkworm production, because then if the silkworms die in that village, all 5 of those people are going to have trouble. So they did try to mix and match, and they have some incentives to put different kinds of groups together for to make it a better system.
I have another question related to that. You mentioned that the network changes based on these interventions, like the microfinancing, and we noticed that a lot of people are losing links. But I'm wondering how the loss of links is correlated with the groups themselves. Are the links lost between people who were not together in these groups, or are they lost within the groups who were together in this microfinancing? Sorry, I don't know if we know the answer to that.
Yes, yeah, that's a good question. So 2 things are true. One, first of all, there's about a 5-year period between that we're looking at in terms of the pre and the post. There's a lot of turnover in links during that time period. So a lot of the links turnover is about a 50% retention rate, something like that. And then what you do tend to see is people who are put in groups that were in groups together in microfinance tend to have increased links between them. And what's happening is they're shedding their outside links at a faster rate. So the people who get loans are actually dropping their links overall, but they're at the same time, they're forming new links to the people they're put in these groups with, and then they're just getting rid of more people on the outside. And then the people who aren't involved are losing links to the people in the groups and to their friends as well. So you are seeing the net positive. There is new link formation among people who are put in the same groups. So those are actually net going up. Yes.
That's very interesting to think about. So you basically you're saying that it gets more clustered, right? Like the network.
Yes. So the clustering overall goes down, but the clustering within these, so you see some occasional cliques sort of forming, but then in the whole graph you're actually seeing lower clustering because of the decrease in density. But you are seeing some local clustering increases in the sense that these little groups tend to be cohesive, and a lot of times once a group works, then they'll keep doing the same group over and over. So they'll borrow and lend, and they'll increase it over time, and they get more money over time if they stay as a group, and there's some incentives to do that.
Right, that makes sense. Thank you.
Sorry, I actually have a follow-on question on that. So I'm wondering if, because there was a 5-year gap between 2006 and 11, and those were the periods in which the experiments were conducted. So I'm wondering if technology or smartphone, prevalence of smartphones or things like that also contributed to the loss of links. And I'm only asking this because you made the statement that people who are getting loans are losing links, but so are the ones that are not getting the microfinance loans. So I'm curious if you looked at technology.
Yes, yeah. And in fact, so there's a lot going on that's causing drops of links across these. And that's why it was important for us. We couldn't have done anything without the 32 villages that didn't get the microfinance, because those are essentially the control villages that we use to estimate the basic drop. So what you see is you see roughly a 15% drop. So take a village that got no loans at all, you're going to see about a 15% drop in density of links in that village. And that's coming partly from technology, partly from the fact that these people are spending more time working outside the village and so forth. So, just the general economic change during this 5-year period in that area is leading to about a 15% drop in the link density across the board for everybody. And then what you're seeing is in these microfinance villages, the fact that you additionally put in the loans, you get an extra 15% drop. So it doubles so instead of just losing 15% of my relationships, I'm losing about 30% of my relationships. And we can't be sure, exactly how much of the 15% is due to, the original 15% is due to technology versus other things. But that the reason that we have the villages with microfinance and not is to be able to do a difference in difference, and then have a bench line, a control group to see that this is sort of a 15% in addition to whatever's coming from the technology. The extra 15% seems to be coming from the microfinance.
Okay, thank you. Another follow-on question is, do you see differences in gender on who loses links? Because the microfinance, as you mentioned, is mostly going to its women. And so in your post-analysis, do you see gender differences, or you also mentioned cost differences initially? So I'm curious to hear that.
Yes, so we don't see systematic gender differences in the dropping of links, but two things are true. One is that the networks are heavily segregated by gender, and these are rural caste, high caste influence systems, in the sense that caste makes a big difference, and they have proscriptions between, say, a married woman talking to an unmarried man outside the family. So things like that. There's a lot of relationships that are basically proscribed, and so you see a lot of structure by gender. The loans, even though they come in through the woman in the house, it's not completely clear where the money goes and how it's used. So if you look at how people are using the money inside the house, it often is being spread among the family members, and in some cases being used for the husband purposes or businesses. The idea that it empowers women seems to be true, in the sense that there's some evidence that it improves their bargaining position inside the household. In terms of what we see in terms of drops of links, it appears uncorrelated with a lot of other demographic variables. It seems to be sort of happening across the board. And that might be because, both the women and the men are losing the socializing that's going on in the village. And whether that be on the women's side or the man's side, we're seeing effects across the board. But, actually the data, a lot of the data we've posted online, we're going to post another set of it. So you can see the original networks from the first studies, the gossip and the previous study. That's on my webpage now. And this new second wave where we're getting the changes, we're going to post that fairly soon. So you can take a look at that. And we haven't, there's so many dimensions that can be looked at on these data, and we haven't yet fully analyzed. But the gender differences are quite striking in the networks.
Thank you.
We have about 1 minute for any last questions. Going once, going twice. Okay, well, thanks so much for. Oh, go ahead.
Sorry, just one last question. Just because you mentioned the way this clustering effect would be more local, I'm really wondering, how can we measure inequality increase or decrease throughout the network in the cases where the network changes so drastically? Is there a measure you think would work better in these cases?
Yeah, I mean, one thing we can do is for instance, just look at the degree distribution, how the links are spread across the population, and to see whether or not we're getting more extreme differences. And we haven't done a full analysis of all the changes. You could be looking at various centrality measures and so forth. We have looked a little bit at some of the financial stuff in terms of how there's changing and who's getting loans from what, and it appears that the lower individuals are getting less money from friends and family, and also not participating in the microfinance. And part of what's happening to them is they're getting more money from money lenders, which turns out to be a fairly expensive way to get it. So you can look at both as sort of economic inequality and social structure inequality. And there's some evidence that you see some increase, but we haven't done a systematic analysis of sort of, how this works. And I think, one thing that's lacking from this study is we don't have really good welfare measures. So we're not, we don't know how happy or what's the ultimate outcome of all this stuff. And so there's net changes and they're going in different directions. But I think what we do take away from it is that when you put in mechanisms in place like this, they have side effects, and we need to understand those side effects better. And that's sort of the main theme, I think, from what the research says.
Yeah, thanks so much.
Thank you.
Thank you so much, Matt, for making time today.
Okay,
We definitely
Pleasure.
learned a lot from your talk, and very interesting idea of considering the repercussions of mechanism design on the general societal structure.
Yes, yeah.
Yeah.
Excellent.
Okay. Well, thank you very much.
Thanks, everybody.
Thanks.
Thanks a lot.
Thank you.
Thank you.